Did you get my joke at the front? I don't know. I thought it was pretty funny, right? Where did the bad triangle go? To prism, right? Anyways, did I tell you why the 2 4s skipped lunch? Did I tell you that one? Because they already ate, obviously. Anyways, some of you told me I was lacking on my jokes, so I kind of picked two. All right. A lot of this, guys, is going to be review, and you're going to draw from previous knowledge. So you have that on your side, but not all of it. You're going to have to know when to use what. So you remember Pythagorean theorem? Good old Pythagorean theorem? We're going to use that. We're going to review that, right? Sum of a triangle, what do the angles always add up to? 180. Things like that are always going to be there, and you're going to have to classify a lot. Not as in CIA classified information, but like naming stuff, right? So we're gonna, a lot of it is gonna be kind of dry at times, but once you get the hang of it, you should be able to answer any question regarding classification of a triangle or a four-sided shape, all right? So you're gonna have to make sure your study sheets are updated regularly, right? Dispreet, right? Dispreet? Did I get your name wrong? It's not Dispreet, is it? I'll have to double check later. Deepinder. Hey, sorry, Deepinder. Apologize for that. What does a week do to my brain, eh? Like it's just bad. This means, okay, symmetry, an isosceles and equilateral triangle can be split in half. Very important. Some students like to split any triangle in half. It's like just split it down the middle. It's like not always. You can only do it with an isosceles or equilateral triangle. You can split it in half because they're symmetric. Symmetric means, right, it can be cut in half and both of them will be exactly the same. This means that the length of the base and the top angle can be divided by 2, right? Length of base and the top angle can be divided by 2, can be split in half. So for example, you see this, right? Follow me, please. You see this, you're like, oh, I just have numbers here. This is the same as that. So let's follow it up with some markings here, right? I put markings there. And so right away, I know this is an isosceles, right? Isosceles triangle because of that. So I can take the 70, split it in half, right? And come up with 35. Right? That's perfect. This 50 can follow me here, centimeters, and the height still stays. And this 80 can also be divided in half and give me the 40 centimeters here. No big deal, right? I think all of you could agree with that. But you can only do it if it's an isosceles or equilateral. You cannot do it otherwise. Okay, look at this next one here. Oh, 100, 100. Yeah, no problem. So I'm going to kind of, oh, what else is 100? You see that? 100, 100, 100. So this whole thing down here is the same. So this one is equilateral. And what do we know about equilateral in particular? I don't need to give you any angles. You know, I'm going to use a different color here. You know that every single angle is going to be 60 degrees. You know that the 180 splits exactly into thirds, right? Perfect. So that means that I can still split that in half, right? And get this to be 30. I can put the 100, right? This 100 centimeter side turns to 100 here. It follows. This 100, you guessed it, right? You can split that in half, makes this 50, and height is still here. I forgot to label two things on both of these triangles. If you're measuring the height, it's always measured with respect to the ground, and we assume that there's a 90 there, correct? And so actually in both of these cases, we could have figured out that third angle at the base here. It could have been done right at the beginning here, or you do it later on here, but I'm not gonna add that just yet, right? We do know that this is 60 here, because I already did the work previously, right? That follows me. So this triangle, actually, you have a lot of information there. You could use sine law, you could use Pythagorean theorem, you name it, it's all there. However, I needed to have an example where this is not the case. I'm sure a lot of you are like, I wouldn't do that. And sometimes you still fall into that because, you know, it just seems like the easiest thing to do. So let's say we have a 90 here. This, you cannot divide by 2. This is wrong, right? This is wrong, okay? We know that this is not symmetric. And you know what the name is for a triangle that isn't symmetric? Asymmetric, yes. It is actually asymmetric would be correct, but in particular, scalene. Scalene is the name we give a triangle that has all 3 sides that are different, right? I'll say this is coming back later. All sides are different. Scalene is the name for a triangle like that. So we cannot divide 100 by 2 and say that this is 50 centimeters. This is also wrong. Everything in here would be wrong if you did that. Like, it's just wrong, okay? So you can't do that. It's asymmetric, that's correct. Not symmetric is the same thing as asymmetric. So keep that in mind. How do you know it's not symmetric? Well, there's no 2 sides that are the same. If 2 sides are the same, boom, you can split that one in half. Just got to be careful. Let's keep going. Okay. What does it say at the top of this one? For each of the following, this is on page 3. For each of the following, fill in the triangle to the right with as much information as possible. Okay. So this one is symmetric, correct? It's an isosceles. It's isosceles. Therefore symmetric. How do you know that? No numbers, right? So you just got to go with the markings here. That tells us that this is isosceles. Okay. That means that, what do we have up top here? That box tells us that it's 90. We divide that in half. So this would be 45 degrees. We know that there's a 90 here. And that height is still, that's the height that we're after. We don't know the bottom side, but we know this, watch. If this is 45 and this is 90, what's this here? Like, we know that 90 and another 90 would add up to 180, right? So this is actually 45 degrees also here. 45 degrees, right? How did I get that? I went 180 minus 90 minus 45, right? That gave me the 45 to fill in this. So you were actually able to fill that in. So this was an isosceles, and you have another isosceles. Do you notice that? This is, how do you know this is an isosceles, guys? Because of the 45-degree angles, it guarantees you that these 2 sides, there's something about pairing things up and when it comes to triangles, right? So if you have a 45 here, a 45 here, Draw arrows to opposite sides, and you know that this side is equal to this side. Guaranteed. So I will make a note here. If you split, right, a right isosceles triangle, you get another right isosceles. Is that? I hope that you see that. I will. You could do that indefinitely. You could in turn split this one in half, like here. Keep splitting like that across the 90. Like the 90 is the point where you start splitting. You would keep getting a smaller. They would keep getting smaller, but they would all be right isosceles. Okay. Actually, can we go back here and just add the word right? It's a right isosceles because of the top box there. It's not just an isosceles, actually specifically a right isosceles, and we'll do more of that later. I'm going to do the attendance here real quick. Based on this triangle, fill in as much as you can here, and then transfer over as much as you can to this one. You have 60 seconds. What? Some of you are Googling it. How do you split this in half? Take a picture. Chat, GPT, let's try this. Anyways. So marking. Okay, I got it. Right, I know this is an equilateral. Something went wrong there. There you go. So it's symmetric, perfect. So this would be my height. That means that there's a 90 there. That means that this is a 30. And this 60, I can just transfer it, or I can just go, right? 180 minus 120 gives me 60. Either way works. So you're done there. Perfect. Oh, I'm missing the 7. And because these markings tell me that this is 7 as well, I can say that this is 3.5, right? I just went 7 divided by 2 to give me the 3.5 centimeters, and you're done. You could use Pythagorean theorem to find height. That's coming up in just a second, okay? These are formulas that you need to have on your study sheet. These are formulas that you will not have on the formula sheet, right? So if you feel like you need help with these, I'm telling you right now, add them to your study sheet. Okay, so I'm going to box this in. And you know what? The trapezoid, I used to use the formula all the time. And it wasn't until I used it at work, I had to like calculate the square footage of like an odd shaped theater. And this was kind of like the shape of the room. Then I realized, the formula calls for A plus B. So you would use the shorter side plus the longer side. Did you notice that A plus B divided by 2? What you're doing is you're taking these two sides and finding the average of it. And you're actually turning this into a rectangle by doing this, A plus B divided by 2. But when you look at the whole formula, you don't necessarily notice that. But it's really saying, hey, find the average of these two sides, right? Turn it into a rectangle and then multiply it by height. So it's like this length times width all over again, just a different way of doing that. So this is the height here, guys. The height is measured with respect to the base. So it would not be this. This is not the height. Some students use this side, plug that in here. It's not right. Okay. So here, parallelogram, it's base times height. So sometimes you can tell that you're going to have to use Pythagorean theorem quite often to figure out this little, like these two sides perhaps to find the height. So keep that in mind, okay? Area of a triangle is base times height divided by 2. No diagram there because I just figured you would know that. And we've talked about that. Okay, so let's review some Pythagorean theorem here. I think I've talked about Pythagorean theorem, but I'm just going to review it real quick here because we're going to use it more often. So only works with right triangles, and you need 2 out of 3 sides. That's basically the checklist for you to be able to use it. And this is the theorem that I like to focus on. I don't use a squared plus b squared equals c squared because it's not always ABC, right? So I just want you to know that the hypotenuse squared is equal to both of the legs squared, then added up. That's basically the theorem, okay? 2 cases to consider. You have the hypotenuse is unknown. In that case, you would just go like this. Hypotenuse is square root of leg squared plus leg squared. That's the formula that I will suggest you have. However, if one of the leg is unknown, you would just go like this. Leg, that the one you want, is square root of hypotenuse squared minus the other leg squared that you would obviously know in this case. So these are my 2. I don't even set it up because this is way quicker, and you should be comfortable with that without manipulating the formula, right? You just know which one to use. The biggest difference is the plus and the minus, right? So that's what I'm going to use extensively all the time. We all know that the hypotenuse is always across the 90, right? Hopefully. So I will make an arrow here. That's how you can easily find the hypotenuse. It's the longest side in a right triangle. Okay? Okay. Next, practice. Calculate the length of the missing side. So real quick, you notice that this is the hypotenuse that's missing, right? You label that. It's like A in this case is my hypotenuse. I use different letters on purpose because quite often for you, C is the hypotenuse, correct? Your teachers would have said C is the hypotenuse. It's not in this case, is it? So I will say hypotenuse is going to be, can we just call these leg and leg? I know some of you want to call leg 1, leg 2, but those are 2 legs there. So I'm just going to take the first one, square it, and add the second one to it, square it. Please don't just give me a final answer. Do the extra step. Doesn't take that long. 7.6 squared. Right? That's 146.12. And then you just square root that. And you get 12.09 centimeters. And it better be the longest side, right? Or else you're in trouble. And it shouldn't be 146 because that would be ridiculous, right? That would be just too much. I'm just going to do this once. I feel like you should all know this. But, right, you would check. So you basically say that the hypotenuse squared is equal to leg squared plus leg squared. That is the basic theorem, right? So you just found out that 12.09 is the hypotenuse. You square that, and then you go 7.6 squared plus 9.4 squared. I already figured out that these two added up is 146.12. And then I'm just going to go 12.09 is 146.12 46, 17. Close enough. It should be exactly the same. Like if we use all the decimals, it should be exactly the same. Did I make a mistake? I feel like I could have, but let's say I used all decimals and square it, right? It would be exactly the same as this. Should be exactly the same, or very close, at least very close. So I don't like to put the equal sign there when it's not exactly equal. So just turn this into squiggly lines like this. This is approximately equal to the right-hand side. So then you know you did things right if you want to check, right? Do you know anybody know what else this helps us to determine? Like if you do this check, this is the check you do to see if a triangle is indeed a right triangle. If I were to give you 3 sides, obviously the hypotenuse would be considered the longest side. If you check this, if you plug those numbers in and both sides are equal, you know you have a right triangle at hand. So I'll tell you this, in construction, when they frame this wall and they stand this wall up with that wall, they meet, right? Somebody, like when they put those walls together, they need to make sure it's at 90 degrees at that corner. So somebody will actually take a measuring tape and go from that corner there straight to this corner here. They'll measure this out, and then they'll do the Pythagorean theorem. They'll actually go, this side squared should be equal to that squared plus this squared. If that is adding up, if that matches, not 100%, but very close, then they know, okay, these walls are at 90 there, we're good. Move on, right? So they're going to double check before they fasten it to the ground and nail everything together. That's a true fact, guys. That's construction for you. In this case, this is the hypotenuse, but that's known to me. So what's missing is that leg there. So in this case, x is going to be square root of 17.8 squared minus 12.6 squared. Notice the minus, right? So 17.8 squared minus 12.6 squared is root of 158.08. And you're like, Mr. Durson, how come you go x and not x squared? Because there's a root on the other side, which implies that a root was taken on this side and canceled out the little 2, exponent of 2, right? So it's accurate to write it like this. So that is 12.57, what are we, centimeters? Inches. There we go. That's my final answer. And it is shorter than the hypotenuse, so we're good to go. And it's within reason. So this is just introducing you to Pythagorean theorem, because you have to be really quick. You can't take, 5 minutes. Yeah. I think if you showed me this and then the answer, that would be fine. But if you make a mistake and you don't show this one, you probably lose more than if you show me the middle step, because then I can tell that you probably just typed it in wrong. Yeah, if you show me a trail of evidence, I'm usually not as harsh when taking marks off. Okay, practice time. I expect you to be able to do the first 2 no problem. The third one, I put in a little tricky one in there, 2 triangles. I think you can handle it. So let's give this a try, a couple minutes, and then we'll move on. The solutions are at the bottom. You see that? They're printed upside down. So you can check if you got that right. So go for it. Take a couple minutes. when you have two triangles, you start with the one that has the most info, right? Regardless, like any unit, if you have trig, there's two, start with the one that has the most info. So I'll call this x in between. Find the side that they share, right? In this case, this happens to be a leg here for looking at this triangle, right? This is the hypotenuse. So x is going to be square root of 89.5 squared minus 68.4 squared. That turns out to be 3,331.69. And then that gives you, watch this. This is probably a bit of an, I tend to do 4 decimals along the way because I'm not quite done yet. I think I'll be fine if you do 2 decimals. But I think if it's asking for x and then p, you can do 2 decimals, 2 decimals. If this is what you need along the way, use 4. At this triangle, I'm missing the hypotenuse, right? So in that case, I would add the 577208, square that, and add the 46.9, square that. That gives me 5,531.3, and that gives me 74.37 centimeters, as the key is already suggesting, right? So that's the final answer. Okay, 4 decimals. Basically, you double along the way, right? Again, if this had been part A, part B, then it's okay to round to 2 decimals and then use your previous answer to do the second part. But that's probably the only new thing there. Keep going. Here's where you need to maybe pay a bit more attention. Properties that are true for all triangles. True for all triangles, right? Obviously has 3 sides. It's a closed figure. You might need this for multiple choice questions, right? Sum of interior angles always 180. I use this one. Sum of triangles equal to 180 if you need to justify. And so let's talk about classifying triangles. Here you have to be careful, okay? When a question asks you to classify a triangle, right? You need to classify a triangle. You're asked to basically find the first and the last name of the triangle. That's how, I hope that helps you to know. It's like you need 2 things, right? We can classify triangles by angle measure and by side length. And I will tell you something, there's a connection between the two, right? Those two are connected, and you'll see that. Sometimes I don't need the side lengths to figure out what it is called based on the side lengths, as long as I have the angles, and vice versa, right? So watch this. If you go by angle measure, there's 3 options: acute, right, obtuse. Right? Acute, all angles are less than 90. If it's a right triangle, like one measures 90 right here. And obtuse, there's one angle that is greater than 90. One. You can't have more than one anyways. Right? One angle that is greater than 90, right? So I would call this is the first name. This is the list of first names that you can give the triangle. I don't care if you flip-flop first name and last name. I really don't. This doesn't have to be in this order, but by side length, this is the last name, so to speak. But each triangle should have both, okay? It could either be equilateral, isosceles, scalene, okay? Watch what it says here for equilateral. All 3 sides are equal, and all angles have equal measure. It kind of says, hey, both of these are true. Isosceles, 2 sides are equal, 2 angles are equal. Scalene, all sides are different, and no angles are equal in measure, right? So that's something to remember. Why can't a triangle have more than one obtuse angle? Explain. Like, look at what it says there. This is my easiest explanation. If you had a 90, or sorry, if you had angle 1 being 91, so angle A is 91 and angle B is 91, there has to be an angle C because by definition a triangle has 3 angles, correct? What does this add up to already? This is 182 degrees. Can't be true, right? Can't be, since all angles add up to 180 degrees, right? So you're already over just by having 2 obtuse angles. So that's basically the main reasoning why you can't have more than 1 obtuse, right? There's no room for that third angle unless it's a -2, but it can't be, right? All right, keep going. So first name, last name. I would have these on my study sheet, obviously very simplified, like very simplified. Don't have it this big, but you even like just have the 3 names, right? For each first and last name. And here we go. This is where I get very creative with how I ask questions. There's like next to nothing online for these types of questions. So I just kind of I know what the province wants you to know and I go backwards and plan it that way, okay? So steps to classify a triangle. What are we at time-wise? Okay, we're okay. This is, can I just say when I give you steps, you don't have to follow them, but if you follow them, you're gonna be safe, right? You're gonna get it most of the time. Look for side lengths and angles given. Look for markings or actual values, right? That's the first step I would take. Second, can you calculate any missing sides or angles? Use PT, you know what that stands for, Pythagorean theorem. Use sum of triangles equal to 180. Or, watch this, sine law or cosine law. It's still there. That's why I teach that before I teach this unit. Conclusion, right? All angles or sides are different. Then it's either acute or obtuse scalene. This is what you need to focus on. Like if all angles and sides are different, then it's scalene for sure. We have to narrow it down between these two, and that's very specific to the case. If you have 2 congruent angles and sides, whoa, what does congruent mean? Equal. If you have 2 equal angles, let's just put, this is the symbol for congruency. It's an equal sign with that third wave. Okay? If you have 2 congruent angles and sides, it's either something isosceles. That's what we know for sure. And if all angles are congruent, it's equilateral. And it's always acute since all angles are 60 degrees, right? Okay. So let's do some classifying. Go ahead. Let's do some classifying here. It starts easy, but then it gets trickier, okay? Classify the following triangles by side lengths and angle measure. I noticed a couple of things. I noticed this. So when it's based on the angle, I know this one is going to be right for sure. And then I have to classify it by side length. Angle measure, right. Side length, what is it going to be? What does this tell me? All are different. All different. So which one would it be? Let's see here. I have it on my study sheet. Side length, I've got these 3 options. Scalene, right? Boom. That's it. That's it. You're done there. That one was easy peasy, right? No numbers. Notice that? Not a, well, the 90 is there. But other than that, very little information. Okay, let's do another one. What would you say this is? If the markings are, it's just like this is actually equilateral triangle, right? So you can actually say, hey, this side across from it and across from this and across from this, since they're all the same, all three sides are the same. Technically, you could say acute equilateral, but you don't have to say acute equilateral because it is always acute. It's always 60, right? Like we know that this is 60, this is 60, this is 60, right? So it's not wrong, but if you leave that, that's fine. Okay. Let's do a couple more so you get the hang of it. So you see that box, right? Immediately I would put down right. No question about that. That's based on angle, right? And what would be the other name? Isosceles, right? Because of the two markings. Do we know what those two angles are that are not there? 45, right? Because if this is 90, take that away from 180, you split the remaining in half because you know that if these two sides are equal, then the angles across from them will be equal as well. So I can actually say that I'm going to go 180 minus 90, divide that by 2. That is 90 divided by 2, which is 45 degrees. So guess what? I could have actually just said 45, 45 instead of the markings, and you should have still been able to arrive to the same conclusion. So either way works. So just use whatever you know about triangles and figure stuff out. Okay, this one. Okay, no markings. You see that? Not a single marking. Numbers. It's focused on numbers. Let's give this a letter, angle C. I can use the sum of a triangle. I use nice and easy numbers here, right? This is 50. So 180 minus 50, that leaves me with 130, which is right up here. So show me the work if you need to do some work. So based on the angle, what do you think this would be called? Obtuse, right? Please follow me because it seems so easy, but then you're going to be like, wait, what? What do I do here, right? So you don't want to be stuck on these ones. It's obtuse because of this, right? It was right because of this. So the angle, all you need is one angle, and you're done with the name for the angle. What is it in terms of the sides, guys? Scalene, how do you know that? Because all angles are different, right? All angles are different, so scalene. Maybe I'm just too excited, but you notice that there's not a single side given, right? You don't need that because you have all three angles. They tell you the story. You don't know what the sides are measurement-wise, but you do know that they'll be different. This will be the longest side here, right, at the bottom. This is across the largest angle. We know stuff like that, but we don't know in particular. Okay, I feel like I need to let you run a little bit because I think you kind of get the picture here. Can you classify all four on this side? Whatever work you do, do it around it. Give it letters if you need letters. Go for it. And then classify. Every single one should have a first and a last name, right? So go for it. And let me see, page 8. We'll do page 8 for now. And if I feel like you got it, then I'm going to let you work for the rest of the class, right? I'm going to go over page 8 here. Notice the relationship, right? If this side has a 25 across from it, and this side measures the same as that one, you can bet, you can put money down that this will also have a 25 across from it. It's like you're copying the same side over, right? So just by you doing this, right, you got the second angle. So if you want to call this angle C, right, angle C would be 180 minus 25 minus 25. Is that 130 again? I need to pick better numbers. So then you have this as 130. And so this is definitely obtuse, right, because of that. And then isosceles. Right? Obtuse isosceles, there it is. And if you say isosceles obtuse, uh, you'll be fine. It doesn't have to be in that order. And then next, you've got the 80 here. Don't be telling me there's another 80 there because it's not, right? This side is across that angle. This side is across that angle. So you can bet that this is going to be isosceles, right? We just need to figure out the first name for this one. So let's call this B and C, and this would be angle A. I probably didn't stress this enough, but we've done this in trig before. These are the same. So you can actually do a marking like that and a marking like that. That tells you that they're the same. I'll just find one of them, right? So angle B will be 180 minus 80. I use nice and easy numbers, right? And I will split that in exactly 2. So that'd be 100 divided by 2, which is 50 degrees. So now you found that this is 50 and this is 50 also because they are the same. That's where the divided by 2 came in. So we know that this is an isosceles. Acute, right? So cute. Anyways, there. Acute isosceles in this case. Okay. Keep going. This one is definitely, you got to go by the diagram here. This tells you that this is obtuse. There's nothing else you can do in this case. When there are numbers, you will see that you need to do something. And the markings are all different, so scalene. This was easy, right? I like those ones. Have those appear on the AC, please. This one is right, for sure. And then I think you know already that this is 45, right? Which tells me that these two sides are the same. So it's isosceles. Right isosceles. You're done for today, right? I think your brain can only handle so much. But here's the kicker. I will ask you to do pages 9 and 10 for homework. Okay? One more thing. Actually, I wanted to pack it here, but go to page 11 real quick. Page 11. You need to be able to go backwards. You need to be able to sketch me a nice triangle. Can you do that? You need to use markings. You need to use numbers if you want. It's up to you. I use markings. Okay, so watch this. I want an acute scalene triangle. Just make it look like this. My pencil is quitting on me. So I'm just going to make it look like this. Like that. And I'm going to make sure all 3 sides are different because of the scalene part. All 3 sides are different. And how do you ensure that it's acute? Just make it look like that. That's all you need to do. Or there is another way of doing this. If you wanted to do this, watch. You ready? You ready for this? What are you telling me there? All 3 angles are different, which tells me that all 3 sides are different. which tells me it's a scalene. Does it look acute? It looks acute. Obtuse would be different, right? Oh, it's obtuse isosceles. Oops. It's a little trickier. So you have to erase maybe. You know how I do an obtuse isosceles? I make the obtuse angle be at the top. So I'll make this be 100 or 110 or 91 or whatever you want, but make it be bigger than 100. And then I'll make these two angles the same. Or, my goodness, stop doing that. Right, you could do 100 and then just go, this angle is the same as that angle. That would also be appropriate. And you know what? You want to make sure you don't lose marks, right? So if you absolutely want to make sure you don't lose marks, you would go like this. 80, 70, that's 150 already, right? So what does this one need to be? 30. There you told me for sure that all the angles are less than 90, which makes sure that that's acute, right? So you should be able to do that. So I'm going to tack on 11 as well. I'm going to post the key to 9, 10, 11. And so the rest are up to you. See if you can match that. I would expect you to know this by tomorrow, right? Classifying.